Here's the equation for half-life. This is exponential decay because our growth factor is less than 1. P0 represents the initial amount. X represents time. And here we would plug in how long it takes to get half of the substance left. So here I would plug in 65. So it says the half-life of a certain radioactive substance is 65 days. So I would put 65 days here, and in 65 days we have half left. If it said in 65 days the amount doubles, I would put 65 here for time, and I would put 2 to represent exponential growth. This P sub 0 means initial. Anything sub 0 is a clue to you that that means the initial. So here there are 3.5 grams present initially. Part A says express the amount of substance remaining as a function of time t. So here we have f of x equals 3.5, the initial amount, times 1/2 to x over 65. In terms of time t, this x should be a t. That means it's in terms of time. Part B says when will there be less than 1 gram remaining? So we're going to solve for x. And 1 gram is going to be the amount that we're looking for. So I'm going to use my calculator. I'm going to go to y equals. I'm going to type in the equation that I have. 3.5 times 1/2 to the x divided by 65. I also want to plug in 1. This is a line that represents 1 gram of the substance. So I want to find where does this exponential decay function meet the 1 gram mark, or the 1 gram line. So a good starting point to look at this graph is zoom fit. So go to zoom, fit. Now the graph that shows up doesn't exactly show us where the intersection is. Here's our exponential decay, and there's our 1 gram line. So first of all, I can't see underneath the 1 gram line, which is important. So I want to go to Window and adjust the Y minimum. So I'm going to change the Y minimum to 0. I'm also going to change the Y max so I can see more X values. I need to find the intersection. So I'm going to change this to, let's say, 100. Now this is more like a guess and check sort of thing. Now I'm going to graph. There's the exponential decay, and there's the 1 gram mark. Now we still cannot see where the exponential decay hits the 1 gram line. So I'm going to go back to Window and give myself more X values. So I'm going to try 150. Because we're pretty close, but it's more than 100. So here's where the exponential function meets the 1 gram line. They want to know when will there be less than 1 gram. So when will we hit the 1 gram line? So I'm going to calculate, so second trace, I'm going to calculate the intersection. So I go to 5, and I hit enter 3 times. This is the first curve. This is the second curve. I don't want to guess, so I hit enter again, and it gives me an X value of 117.48. Now, if I said when, I need to give a realistic answer. So this says 117 days and 0.48 of the next day. So it really happens on 118 days. So my answer to part B would be 118 days will give me less than 1 gram remaining of this certain radioactive substance. For the Newton's law of cooling, we're going to need to remember something that we learned back in Algebra 2. We're going to need to be able to solve for a value in the exponent when the base is e. Well, let's remember, back in Algebra 2, we learned that when I have e to the x, and I take the natural log of e to the x, what happens is the natural log and the e cancel out. So I just get x. So let's look at this example. We need to be able to solve for k. Well, in order to get k out of the exponent, I need to take the natural log of both sides.